Hello friends, welcome to G-Centric. So we will see question number 151 which has been appeared in GATE 2016 electrical branch. Okay, so in the circuit shown the maximum power which is given in watts. Okay, so we have to calculate in terms of watts delivered to the resistor is. Okay, so to this resistor they are asking maximum power delivered. So we have to apply maximum power theorem. Okay, so now if you see in this circuit, it can be replaced with, okay, so this can be eliminated, okay, and now here we can replace with VTH, RTH and this resistor R. So what we have to find? We have to find only the power delivered in this R, that is the maximum power. So condition for this we know R will be equal to RS. Okay, so but here there is no RS, so we have to calculate, so it should be equal to RTH, right? So for this condition what will be P max? We already know it is V square TH divided by 4 times R Thevenin, right? So from this one we have to calculate VTH and RTH. Next, coming to this one, okay, so I'll apply KVL in this circuit so that I'll get current I. So this current will be in this and this current will be flowing in this. So if you have to calculate the current in this one, you have to know what is V0. There will be 2 unknown. So first thing we will calculate from here, then we will find the V0, then we will substitute the value here, okay, then we can find the current through this one. Okay, so now we will apply the KVL there, 5 volts, then if current is flowing here, so this will be the direction, it is already given. Okay, so that is minus 5 K times I equal to 0. Okay, so here from here what we will get? We will get this as 5 is equal to 5 kilo times I. Okay, so then a current I will be 1 milliampere. So let me check if this is correct answer. Yeah, it is 1 milliampere. Okay, so this much of current is flowing through that one. So when 1 milliampere is flowing, V0 can be found easily. So what will be V0 equal to? 2 kilo divided by 1 milli, right? So this will be how much? 2 volts. Okay, so this will be the, it is 1 milli. Right, it's a V is equal to I into R. So once you know V0, you can find 100 times V0. It is nothing but 200 volts. Okay, so this is 200. Now either you can apply using KVL, you can take voltage division rule, or you can use nodal analysis. So if I use nodal analysis, this is nothing but VTH. Voltage division rule, what? If you find it here, same voltage will appear across R, that is nothing but VTH, right? So now if you have to find through nodal analysis, it is VTH minus 200 divided by 10 kilo plus VTH divided by 40 kilo, right? This is equal to 0. Then LCM is 40k, so this is 4 VTH and minus 800 plus VTH equal to 0. So 5 VTH will be equal to 800 and VTH comes out to be 160 volts. Okay, so we came to know what is VTH. Now coming to calculation of RTH. Now in this also you can apply either second case, that is the first case, that is the short circuit current, or the second one, so which is the shorting the voltage source or opening the current source. So since it will be very easy to calculate using the short circuit method, okay, so we can short circuit this one. Okay, when it is short circuited, here it is 0 volt, so this will be also 0 volt. What will happen? This branch will have no importance. So now I can easily find current ISC. Okay, so if you have to calculate RTH, it's nothing but VTH upon ISC. So VTH we already know, we have to find ISC, then go with the V by this R. So this V is 200 divided by 10 kilo. So what it will be, how much? 20 milli ohms. Okay, sorry, milliampere. So now substitute this in this one. You will get voltage is 160. Okay, so this is V Thevenin voltage divided by 20 into 10 to the power 3. Okay, so this will be 8 kilo ohms. So this is how you will find the R Thevenin and V Thevenin with the help of short circuit current. So what we have to find next? We have to find P max, right? So what will be P max? 160 into 160 divided by 4 into 8 into 10 to the power 3. So this gets cancelled with this one, and this is 20, this 3, okay, it will be 0.8 watts. So this is the answer for this question. Next, coming to this 152nd question, we have in the circuit shown Vs is constant voltage source and IL is constant current load. So, okay, so this is current load and this is the constant voltage source. We have to find the value of IL that maximize the power absorbed by the current load is. Okay, so in terms of this equation, we have to find the current load IL. Okay, so this is the load. Okay, now what is meant by observed? It is nothing but if it is V, then the current will be flowing in this direction. This is plus minus, here also plus minus, means its current is being observed. Okay, so this source is observing the power. So now what is the power defined as? IL into VL. So to find the VL, we want IL. So how do we find VL? VL is nothing but apply the KVL. Here in this case it is VL only. We will take this as, okay, so this voltage drop as VL. Okay, and here we will take it as R, and we will apply KVL. Applying KVL in this loop, we will get Vs minus IL into R minus VL equal to 0. Okay, so now we will equate in terms of VL because we do not want this VL. We have to eliminate that. So VL is nothing but equal to Vs times I into R. So substitute this in this one. So P is equal to IL into Vs minus IL into R. Okay. So now cross multiply inside, IL into Vs minus I square L into R. So next, what is the condition for the maximum? We have to differentiate with the one which is through which we want the current. Okay, so this is nothing but dP divided by dIL. So we want power across IL, right? So while we and equate them to 0. So differentiate it, we will get Vs minus 2 times of IL into R equal to 0. So we want IL. If I take the Vs, you will get IL is equal to Vs times divided by 2R. So our correct option is B. Okay. So now if you know the concept, it will be very easy to solve. So we have applied only KVL and the power formula. So we know what is the condition for the maximum. So here the maximum power observed will be differentiation of this with respect to current load. So you will get this answer. Okay, you have to then equate to 0. So we will see some more questions based on maximum power theorem. So coming to this next question, that is 153. Okay, so we have got a circuit of, this is the AC circuit. Okay, so find RL for maximum power transfer, this one, and also find efficiency. Okay, so next, first check whenever the AC problem comes if the inductors and the capacitors are in ohmic value. So they are already in the ohmic value. So we will solve the problem. So now if I have to replace this one with Thevenin circuit, this will be open, right? So I will draw its equivalent. It is VTH. Okay, so then we have ZTH, because it is, since the inductor is also involved, we have ZTH. So now this is RL. Okay, so we have to find both this one. Okay, so now we know that this is the VTH. Alright, so we can solve it using nodal analysis. So how do you find using the nodal analysis? It is VTH minus, okay, so let us take this as plus and minus 100 angle 0 degree divided by 6 plus 8j. Okay, then we have plus VTH, this is open, minus 90 0 degree divided by again 6 plus 8j, there is no incoming, so equal to 0 degree. So these both are same, so when it goes over that side it will be 0. Since LCM is same, directly we can add 2 VTH minus, sorry, this is 110, okay, 200 angle 0 degree. So what will be VTH? 100 angle 0 degree volts. So we got our VTH. Now to find the ZTH, okay, so how do you find ZTH? It is nothing but short the circuits. Okay, so when you short the circuit, both of them are shorted. Okay, so this is open, but this is the terminal we have got here, that's why they are in parallel. So when they are in parallel, what do we get ZTH as equal to? It will be half, since they have the same value 6 plus 8j, it will be half of their value, that is R plus J4 ohms. Okay, so this is the ZTH and VTH. Now we have to find the maximum power, which is nothing but I square L into RL. So now we do not know what is the value of RL, but we know we can apply current here. From this one we already have this as 100 angle 0 degree and this ZTH as 3 plus 4j ohms. Okay, so I can find the value of I. So current I will be equal to, so before that what I have to find? I have to find RL. I do not know what is RL also, but I know that RL will be equal to ZTH. Okay, that is because RL is variable, it is the first case. Okay, so when it is the first case, then how do I find RL? It is nothing but square of 3 square plus 4 square, so which comes out to be 5 ohms. So this is 5 ohms. Now I can find current IL. Okay, so to apply for the maximum power transfer, right? So how much it will be? I is equal to 0 divided by 3 plus 5 is 8 and 8 plus 4j amperes. Okay, so when you solve this one, you will get the current as I is equal to 11.185 angle minus 26.56 amperes. Okay, so this much amount of current you will get through this circuit. Now if I substitute in this one, I will get P max is equal to square of this one. So that will be, but while we have to calculating power, we have to take the magnitude, not the angle. So it will comes out to be approximately 625 watts. Okay, so when it is 625 watts, we have got the, this is nothing but the power output. But what we want also for the efficiency. So we need input power. Okay, so I'll rub till here. So what is input power? P input will be equal to VL into IL cos phi. Okay, so since we have got here cos phi, this is a AC analysis, so do not use the formula of output power by input power. So this will be wrong. Use this formula. So now here also VL is how much? 100 0 degree into IL is 11.185 angle minus 26.56, right? So now this is the till here including the angle, but we do not know what is phi. So basically what is phi? It is nothing but the angle between current and voltage. Okay, so while calculating P input, see if you observe here it is 0 degrees. So if you take V as the reference one, then current since it has negative sign, it will be lagging by 26.56. So this is only our phi. Okay, so now I'll take only the angle because magnitude I am going to take here, angle I am going to take here phi. So P input will be equal to 100 into 11.185 cos of minus 26.56. So you will get input as 1000 watts. This is approximate. So now you can easily find out the efficiency. So what is the efficiency? Input power by output power. So input power is nothing but 625 is the output power and input is 1000 into 100. So you will get 62.5%. Okay, so this is the method to calculate for the AC analysis. Next, coming to 154th question. Okay, so this is 154. Now we have to find RL for P max. Okay, so this is the load here. I'll just rub this one. So here this is the load, and what is variable? RL is variable. So we know that for the condition of the maximum, in this case when the impedance is given and RL is variable, it is nothing but it will be equal to RS square plus XL minus XC the whole square. Okay, so for this one substitute whatever we have. RS is nothing but 10 square plus XL is 10, minus of minus is 15. So it will be together 25 square, and square root of 725 will comes out to be approximately 26.9 ohms. Okay, so next what will be, this is the condition for the maximum, right? So that is the value of RL. Next, coming to this 155th question. Sorry, I have written this question half, and it is XC is variable in this case. And when XC is variable, we know it is the condition of fourth case, right? So directly we can write here XC is nothing but minus XL. So what is XL? We have 10. So XC will be equal to minus 10 J ohms. Okay. So this is the answer for this question. Now till here we will complete the maximum power transfer theorem. In the next lecture we will move on to the reciprocity theorem. Thank you.